You're welcome to another video of Yang-based network automation using netconf, restconf, and GNMI. In this section, we'll talk about using Jinja2 template in netconf protocol, which is a common configuration template for many network devices, in which in the simplest form, the configuration data are replaced by the variables, but it has more capabilities like conditions and loops. It also helps us to separate network device configurations from automation script. In this section, we will have a demonstration how to use Jinja2 template in netconf protocol. We already discussed how to write a simple and advanced Jinja2 configuration template in the course CLI-based network automation using Python Nonier. But just to review, we use Nonier plugin to take inventory advantage of this plugin, which help us to separate inventory information and credentials from the automation script. With the use of Jinja2 configuration template, we create a common configuration template for many network devices and also separate it from the automation script. In the simplest form, the configuration templates use variables that are replaced by the data of the respective network devices at the time of the configuration deployment. Jinja2 template also has other programming features like loops and conditionals. The data of each network device is also kept separate from the network automation script, replacing the variable at the time that configuration template are deployed to the network devices. All these concepts can also be used to change the configuration of network devices with netconf protocol. The only difference is that we use XML-based Yang structured configuration template instead of CLI-based configuration template that we have used in the previous course to deploy to the network devices. This is the automation script used to change the configuration of network devices using Jinja2 configuration template and netconf protocol. The task load YAML from the Nonier utils plugin is used to load YAML data into a dictionary structure. Here there is a YAML data file for each network device inside host vars folder. The loaded YAML file will be kept inside the dictionary variable with the name of network device and hdata key. In other words, host.hdata is used to access to the root of data for each network devices. The task template file from Nonier Jinja2 plugin is used to load Jinja2 configuration template and apply loaded data to the configuration template to extract configuration for each network device. And the final configuration will be deployed to the network devices using netconf edit config from Nonier Scraply or Nonier netconf plugins. The data of router R1 is located inside hostVars r1.yaml file. The configuration related to OSPF routing protocol, including process ID, router ID, and network and area numbers are stored inside this file. The process ID and network numbers are a list of data which can be accessed using a loop logic. This is the OSPF configuration in the format of Yang data structure that we have used in the previous section to deploy through netconf protocol. Exactly the same configuration is converted to the Jinja2 template format using variable substitution and for loops in the template folder. This is the Jinja2 configuration template which we use in this section to apply to the network devices. Host.hdata is used to access to the root of data dictionary of each network device. For example, host.hdata.ospf.process_id is used to access the list of OSPF process ID for each network device, or the variable host.hdata.ospf.networks is to access the list of network numbers to be configured in each network device. The variable host.hdata.ospf network wide mask and area are to access the wide mask and area number for each network device. Two for loops 1 and 2 for loops are used to access the list of OSPF process ID and also OSPF networks. All other parts of the Jinja2 template are exactly the same as what we deployed on network devices without Jinja2 template in the previous section. To use Jinja2 template in automation script, beforehand, we have to install Nornier Jinja2 plugin with the command Python 3 pip install and Nornier Jinja2. Make sure that the Nornier Jinja2 template is already configured in your automation machine. For me, it is already installed, requirement already satisfied. Before we run the automation script, let's check the current OSPF configuration of network device with the command show running config section router OSPF. Now we run the script to see the result of the configuration before that we change a network in router R1 YAML data file. But before that, I have to make sure that the operation replace is removed from the Jinja2 template. I will explain it now. And then Python 3.12.9. As you can see, the previous configuration of OSPF was this configuration, but we have used 111, 12, 13, and 14. In addition to these four networks, the network 10 was already in the configuration of router OSPF, and by default we expect that the configuration is merged with the current configuration. If we check again the configuration, you see that the current configuration is merged with the new configuration. Since we have not used the operation replace in Jinja2 template, now we can add again inside the Jinja2 template in any section router OSPF or OSPF the operation replace to replace the current configuration with the new configuration. Also change the host vars R1, change 111 to 11, and again we run the script and we expect that the configuration is replaced and only network 11, 12, 13, and 14 is the OSPF the configuration. The connection is disrupted. I can check through the console section router OSPF, and as you can see the configuration is completely replaced with a new configuration.